Alright, hello everybody, welcome to another beautiful lesson in Algebra 2. Today we're going to be talking about finding the roots of different polynomials. So we're coming to a closing of our unit on polynomials, and so a major thing to finish this off is just talking about the different roots, whether it be real roots or imaginary roots for a polynomial. So we're going to start, we're going to work through several different examples, but I'm just going to start with this example here. So we're going to be finding the roots or solutions. Let me get this together. Finding the roots or solutions of x cubed minus 2x squared plus 6x minus 12 equals 0. And so what we're going to do here is you're looking for particular things when you see a polynomial. You can't automatically say, oh, okay, I need to do this or I need to do that. First, you have to take into consideration what you have. So when I'm looking at this, I have 4 different terms. And if I look at every 2 terms, so these first 2 terms, they have an x in common, 2 x's in common. These last 2 terms, they have factor 6 in common. So what I can do here is to factor this is start by factoring out the GCF, the greatest common factor. So this has 2 x's, this has 2 x's. If I divide that out here, I'm going to be left with an x, or factor it out rather. If I factor it out here, dividing, I'm going to be left with minus 2. Bring down the plus sign. Then the same, I'm going to factor out the GCF here, which is 6. I'll be left with x, and 12 divided by 6 will give me minus 2. And bring down the equal 0. Next, here I can factor out an x minus 2 in both of these 2 expressions or terms. So I have x minus 2, and then what remains is the x squared plus 6. So that becomes our second factor, and this is all equal to 0. Okay. So to find the roots or solutions, the first thing I'm going to do is factor it. Next, once I've factored, I'm going to set each of these equal to 0 separately, because the idea here is I want this multiplication of these 2 binomials to equal 0. So by our 0 property, what that tells us is that this x minus 2 can equal 0, because 0 times anything is 0, or this x squared plus 6 could equal 0, because that 0 times the x minus 2 will still be 0. So we set it equal to 0 separately, each factor. And then we just solve for x. So we're going to add 2 to both sides. This is going to give us x equals 2 here. Then over here, we're going to subtract 6 first, because we always want to get rid of addition and subtraction before we deal with any exponents. And then the only way to get rid of the exponent of 2 is to take the square root. So I take the square root of x squared to get x. I take the square root of negative 6. I'm just going to have the square root of negative 6. Here is where you have to remember that we can't take the square root of a negative and get a real number. So what's going to happen is we're going to have an imaginary number. So we put an I outside of our root and get rid of the negative. And we can't forget that we must also use the negative of this, because we're taking our square root here. So here are our 3 roots of this polynomial: 2, I times the square root of 6, and negative I times the square root of 6. So we have 1 positive, 2 is positive, and it's a real root. Then we have a positive, what we call an imaginary root, because I is the imaginary unit. And then lastly, we have what's a negative imaginary root. So this is a scenario that can happen when we take the when we find the roots. We have example 2 here. So we're going to find the roots of solutions of x to the 4th minus x squared equals 0. So here, notice that we now have two different terms, and both of these terms have a common factor, which is x and x squared. So we're going to factor out the GCF here. So that's how we're going to start. So if I were to factor out x squared from x to the 4th, I'd be left with an x squared. And then if I factored out x squared from x squared, I'm going to be left with 1. Next, I'm going to set each of these equal to 0 separately. So I have x squared equals 0 and x squared minus 1 equals 0. Again, I'm trying to find the roots, so I need to get the x by itself. So on the left side over here, when I take the square root, I'm going to be left with x equals the square root of 0, which is just 0. And then over here, if you notice, there's a couple things here. So one, we could have chosen to factor this into a difference of squares and then find the values of x here, or we can just simply find that for this, solve for x for this polynomial. So we're going to add 1 to both sides. I'm trying to get it to focus. Okay. Then we're going to have x squared equals a positive 1. Lastly, we're trying to get the x by itself, so we take the square root. And then the square root of 1 is a positive 1. And don't forget, we can also get negative 1. So that's one of the tricky parts about square roots. You have to remember the positive and negative. Negative 1 times negative 1 is 1, and 1 times 1 is 1. So here are our three roots here. So we have one real positive root, we have a real negative root, and then we have a real root here as well. 0 is neither positive or negative, so it's just the real root. So we have our three roots here. Alright, another example of finding the roots of solutions. Let's say we have the polynomial x cubed plus 6x squared plus 9x equals 0. So again, we have to assess the different terms that we have in the polynomial. So we have a term with x, another term with x, and a third term with x in these three terms. So since all of these have x, what we can start off by doing is just factoring out that x from the three terms. So if we factor out x from here, we'll be left with x squared. From 6x squared, factoring out, we'll be left with just 6x. And then from 9x, factoring out the x, we'll be left with 9. Bring down the equal 0. Within this parentheses here, we can factor this quadratic function. So going back to factoring quadratics, we're looking for a number that we multiply to get the 9 here, but adds to get the 6. And you can also do kind of like some guess and check here. But I know for sure that this 9, I can multiply 3 times 3 to get 9. And then if I add 3 plus 3, I'm going to get 6. So I know that's going to be the result here. And then the x squared, if I factor that, I'll get x times x. So that's how I know what my factors are for this quadratic within the parentheses. And you can double check by foiling. X times x is x squared, 3x is 6x, and then 3 times 3, that's 9. Alright, and then finally with these factors that I have, I can set each equal to 0 to find the value of x. So x equals 0, x plus 3 equals 0, and x plus 3 equals 0. So I already have it here, x plus 0 is just x plus 0. I'm sorry, x equals 0 is just x equals 0. So that's one factor. That's one real root. Then if we have x plus 3 equals 0, solving for x, I'm going to get x equals negative 3. So here we have a negative real root. And that repeats again. I have another x plus 3 equals 0. So this is going to give me x equals negative 3 a second time. So we have another negative real root. And so we have an interesting new concept here that happens when you have a root that gets repeated. We have a name for this called multiplicity. So what we say is the root negative 3 has a multiplicity of 2, because that's how many times we would get that root if we solve the factors for x. So we have all real roots here, one negative and one neutral, so to speak. And so if you've noticed in all of these, as we've been finding the roots, the number of roots that we have or solutions should match this highest exponent or degree that we have in the polynomial. So you can go back and check that for the previous examples as well, and make sure you're checking the multiplicity to coincide with that. Because if we hadn't considered this third root here, we would only have 2, which doesn't match our exponent. Our exponent or degree. But if we consider that multiplicity, that we have this root of negative 3 appearing twice, that's how we get to that fact that there are 3 different roots that should always be the case to match our largest exponent. We're going to finish off with one last example of finding the roots of solutions or solutions of a polynomial. So we're finishing off with x to the 4th minus 1 equals 0. So here again we want to assess the type of polynomial we have. We have 2 different terms, one with x and one without it. That's just a constant. So we can't factor out anything from both here, but we can use our formulas for special polynomials. So if we notice this exponent here, we can write this as a square. If we kind of go back to what we learned about exponents and use some knowledge of that here. So if we chose to rewrite this, x squared squared is how we would get x to the 4th. Remember, outside of the parentheses, we multiplied the exponents. And then 1 is 1 squared. So what we actually have here is a difference of squares, which means that we can use the difference of squares formula to factor here. So our first term, our a, so to speak, is our x squared. And then our second term, our b, so to speak, is 1. Remember, one is positive and the other is negative. Feel free to pause here and FOIL to check the work here that you're going to get x to the 4th minus 1. Alright, next we can set each of these factors equal to 0 separately. So I'm going to add 1 to both sides. I have x squared equals 1. Take the square root. X equals square root of 1. Remember, there's a positive and a negative when we take the square root. I'm going to do the same thing over here, but I'm subtracting 1 instead. I have x squared equals negative 1. I can only take the square root. Again, that negative 1 is going to give me x equals I. The square root of negative 1 equals I. And I also have to use negative I. So these are my 4 roots here. I have 2 real roots and 2 imaginary roots. 1 positive, 1 negative, 1 positive, 1 negative. So that completes what we've talked about with finding roots and solutions. There are several different cases, so you have to be careful about looking for patterns to show you what method to use.